Well, hi, and thanks for joining me here in my shop as I'm going to start another radio, a really nice multi-band shortwave radio. This, of course, is the cabinet. The radio's sitting right there. So it's out of the cabinet because right off the bat there's a really serious problem with this radio, and that is it's missing its dial glass. It has no dial. There's no dial. The dial glass is broken, so I am attempting to secure a new glass. It looks pretty optimistic. Newly manufactured glass from a supplier. If that comes through, then you'll see it and I'll tell you where I got it. No secrets about this on the internet. If you're doing this kind of work, you probably know which company I'm talking about already. So apparently they don't make one exactly for this radio, but there's other models, RCA radio models so similar that their dial glass will probably work in here. So that's where that stands. So no dial glass, not much of a radio, unfortunately. That's kind of the situation with these. Now, before I put the cabinet away, let's look in the back. Oh my God, it's loaded with asbestos. So a lot of these radios have an asbestos sheet laid on the bottom, and that sheet can be in various states of condition. This is in really poor condition. So in fact, my warning hackles are my warning quotes are going. Why quotes? I don't know. So to get the asbestos out of here, and I certainly want to get it out, it's all broken up, moving the chassis in and out, scrapes over top of this, releasing fibers. You don't want to release fibers. So when I'll take this out, it will be outside of the house. I do have a mask like this I will be wearing, and I'll take that asbestos out. Now what do you do with this dangerous material? Well, in this volume, this amount, which is a very small amount of asbestos in terms of industrial problems with asbestos, this is a very small amount. All I got to do is put it in a couple of plastic bags, throw it in the regular garbage that's headed for the landfill. That's all I have to do. So also, if you look, you'll see there are staples whacked through it, which is what is keeping it in the radio. So before I try to take it out, because I want to bring this out with the least amount of turning it into airborne particulates, right? I'll pop those out very carefully, and then you probably use a scraper or something, get underneath the asbestos and try to remove it as one sheet right into the bag outside, and it's gone. So for those of you who are concerned about asbestos, please read up on it. I have a little bit of training and background from industrial exposure to asbestos in the past in the electrical industry. So I'm not terribly concerned to be standing here looking at that. That doesn't scare me. Fiddling with it does. So the way it goes, that's the end of the cabinet. Oh, we got some information in there. So there's a tube layout chart here, and of course the inevitable list of patents. This set is designed for and equipped with genuine radiotrons. You see the front panel, the inside panel is kind of falling away a little bit, and just frankly a little bit surprised there is a piece of glass here that seems to fit perfectly. It looks like it's been in there all the time, but nothing on it whatsoever. So two pieces of glass in this radio? I can't imagine. Or did somebody clean off the back of this and remove all the markings? I don't know. Don't know how it got to be the way it is. Oh, one more thing in this radio. So these radios come with an odd little antenna. Here's what's left of it. So this card is slid in slots on the top here, like this. Okay. So when I got the radio, this is how it was. When I pulled this out, it's missing its wire. There should be a wire a few feet long going around this. It's just completely missing. So this is called the capacitance antenna. Exactly how this helps the radio, I don't know, but the radios that are very similar to this style, I'll show you one or two things to look for to see if you've got a radio like this, because there's 4 or 5 models that are very, very similar. This is supposed to be connected to the antenna with a wire down here and just sitting up here in the top. And again, I don't quite understand, well, I'm going to put it back in the cabinet in fact, why this is helpful to the radio. I think we'll see it on the schematic eventually. It'll be called a capacitance antenna. So this cabinet has been refinished also, and in fact probably on camera you wouldn't think it was refinished. You'd probably think it looks original, and standing here it looks original too. Whoever did the refinishing job did a real nice job on this because it looks original. A lot of refinished cabinets just don't quite get back to the original look. And, so this is in great shape. And the guy who did the refinishing did everything he could to keep the words on the front. Now, how's this coming across? Yeah, you can see quite clearly what he did was he masked over the words with a little bit of tape of some sort. And then he did his refinishing work, and then he lifted the tape off, revealing the original words and the original finish. How good a result that is, I've seen a lot of radios where this effort has not been done. In fact, the whole thing is just cleaned off, words gone. I don't know. I don't know what to think. There's probably some way of cleaning it right off and then re-establishing the wording afterwards. I'm sure there is. Anyway, that's the story on the cabinet. Okay, let's take a closer look at the radio. Pretty dusty all through here. Let's turn and see. Good. Okay, the string is there. Spring. This doesn't look right. This doesn't look right. This looks like it's not pulling hard enough. Expect these springs to be stretched further. So that's a hint that this radio has been, I think it's been restrung, and I'm not sure it's done correctly. Well, who knows? It's working anyway. This seems to work okay. Yeah, it seems to be okay. We'll find out as we go. Antenna's intact. What that was. Ooh, a dusty, dusty radio. Very dusty radio. Lots of dust on the power cord too. Don't think this guy's been plugged in for quite a while. Let's pull this out of here. Yeah, this guy's not been plugged in for quite a while. No fingerprints. It's got all his tubes. Everything looks pretty good. So on the back of the tuning capacitor is a dial marker system here, if you like, that enables this radio to be worked on a bench like mine without having it in the cabinet where the glass dial plate would be if it were there. So that's a great thing. Even without the glass dial plate, I can completely align this radio while I wait for the plate to come. Just looking down to see if there's anything dropped down in there. No. Okay, just a lot of dust. It's got a pretty nice antenna on it. So this would be the part that's resonating with the signal, and this is the part that's feeding right into the radio. And then there should be shortwave antenna. Open link when using external antenna. So one of the things about selling these radios back in the day was if you said to the buyer, and you have to hang an antenna outside your house, they'd probably say, well, can you show me something else then? And eventually you would show them a radio and you would say, well, this radio you can use without an external antenna. Just close the link here, and on AM that's going to work quite well because you're really going to rely on this loop antenna, which is really a great antenna, no doubt about it. But for shortwave, not going to work too well. You really do need that wire antenna. And as much as all these radios were made in North America with shortwave in them, at the same time the AM radio, television, and FM coming along in the late 50s was just kind of pushing shortwave aside in North America. And so it is today, pushed totally aside. Let's look underneath here. pushed totally aside in the sense that North America and shortwave, those two things don't go together very well anymore unless you're just a hobbyist. What do we got here? Let's take a look. Let's see. Okay, first we got some asbestos hanging around. So I'm going to clean that off. These little flakes of it here. I'll clean that off. Here's the power cord connection. Done with these. I'm going to undo these. Look at this. And this is not good. Don't put these in your radio. Don't rely on tape. Solder every connection. Okay, so there's a list of things wrong here. The main thing that's wrong with doing this technique here of connecting it. You should have soldered it right back to here, but you see the person didn't have any solder, right? No solder. So, no soldering iron. The problem with putting the cord in and just grommeting on, one of the problems anyway, is the cord is not strain relieved. And you're tugging right on the wires that go right into the power transformer. This one doesn't matter much. Tugging on this, it's just soldered here, wouldn't really cause a problem. Tugging on these wires is a bad thing. These wires become extremely stiff in here. And if you do manage to bend them, there's a good chance you're just going to crack the insulation on the wire. Now you've got a bit of an insulation problem. You're on your way to getting some kind of short circuit happening down in here. You can't make repairs down in here, or at least there's nothing easy you can do. And power transformer, you really don't want that to be damaged in these radios. That's one of the parts you really can't afford to replace. Pretty much everything else you can pretty much replace. I mean, I take that back. All these coils that are up here, aside from rewinding them, this is more you do not want to replace. Now, as I'm talking, I'm looking the radio over. You probably are too. And I've caught something. Something has caught my attention. I won't reveal it just yet. So, if you look at the capacitors, these are all originals. I mean, I'd be shocked if they weren't. This one's just a little different. Now, this guy is coming right off the. So what I'm trying to do here is determine if somebody else has worked on this radio. I mean, it's obvious this grommet thing was done, but if they used grommets on the wires down here, there's no way they soldered parts in. So that would mean somebody else was in here, or this is another original part. So this is coming right off the volume control slider. Let's take a closer look at that as soon as I find my, because I think there's evidence that is interesting to look at. So here's the capacitor I'm pondering. You know what, I'm going to stop for a minute and fix the focus on this camera, or it's going to drive us nuts here. Just hang on a moment. Okay, let's see what we can see with this camera. So this capacitor caught my attention because it doesn't match the rest. If we look down at the volume control where it's soldered, if we can do that. Well, I was going to say the solder on that center post looks pretty new because it's very shiny, but in fact it looks pretty new over there too, on that post. Well, I'm not sure we're going to be able to say for sure. If anybody did anything, oh, it looks new down there. So someone has changed this one capacitor. Now that's a pretty important capacitor. The audio signal passes through this capacitor from the volume control and goes onto the grid of the first audio amplifier, the preamp if you like. So a trouble in here can easily just quiet the whole radio down and cause some other problems. Just funny somebody would change that one and nothing else. Nothing else I found so far. Okay, so we're going to examine the whole radio now. Close up, starting at the bottom here, and I'll show you the thing I encountered. We'll see what else we encounter. So there's those ugly capacitors there. A bunch of resistors look to be in good shape. Here's how they look and how they are. Two different things. Let's look at this transformer closely. I was pondering. You can see the compound freezing all the wires right in the opening there, and some of that compound easily leak down into the wires and just further make make them rigid. These ones don't look like the goop has leaked down into them, but these are stiff as can be. No bending of these wires. They are where they are. That's why I'm pretty worried about this red one here. Now, how did he get away with this one? It's locked in there. You know, it's pretty much luck. In fact, look at what they did here. This is either the original power cord or this is an even earlier replacement. And you see the kind of tape that's used here? This is friction tape, or in Canada we would tend to call that hockey tape. That's actually not bad tape to use in these kinds of circumstances. It stands up well over time. It becomes solid and hard, whereas this stuff does exactly that. It becomes, the glue gives up on it, and it just comes off. This modern tape, it's not nearly as good as the friction tape. So my guess is under there is a soldered connection. Why don't we find out? I'm going to remake all this anyway, so I'm just going to nip that right off there. Say goodbye. Now I'm shortening up a wire. You know, there's only so much, but there's actually quite a bit here, so I'm not too worried. Why don't we take a look at this now and just see what did somebody do here previously. I just pull on it and the insulation just gives right out. See, like if I, let's see, this stuff's pretty flexible here. Yeah, that's pretty good actually. So I can't imagine this is original. So we're probably looking at a replacement on a replacement. I'm kind of curious about what was going wrong with the power cords that somebody had to replace it repeatedly. I don't know. Just hack this stuff off here. Let's see what's underneath. Is it soldered? Yeah, I think it is. Let's see. I'm looking here. Look on the close-up camera with you. It looks like it's barely soldered. Yeah, it's definitely soldered. So whoever did this. So this is the soldering of the first power cord replacement. And the second power cord replacement, of course, went on with these things. Don't use these on your radio. Get a soldering iron. Learn to use it. Holy smokes. Lots of debris there. Okay, so much for that. When I get around to it, I'll just nip this wire off the switch there on the back of the radio and just put the new cord right up to that. When I get around to it. Okay, back to what we were doing here. We're working our way through the radio. Another bad capacitor. Now in behind it is a black molded capacitor. I've had good and bad luck with these guys. Generally, molded capacitors aren't much better than the paper ones. Some of them are even worse. Hunt's, for instance, is worse. I think something else just caught my eye. These are small. Is that a crack through there? I think that's a crack right through it. Because I don't think you see a matching piece on the other side. So you know, that gives you an idea what happens here. This thing is cracked. Almost certainly moisture's gotten in. Moisture's probably gotten in through the ends here anyway. Probably bad. This one looks a little better. Whoops. Let me try and see if I can hold still here. But, oh, it's got a crack. Is that the same one? They both got cracks in exactly the same place. Just a second here. There. Huh? It's cracked. Isn't that interesting? Well, I find it interesting. So here's another thing that caught my eye. If you look at this capacitor and trace it along, oh, so that looks like a replacement job. But this is going to the phono jack on the back. So why would somebody replace this one capacitor with a really old capacitor? Well, you got me, because this is just about the least important capacitor in the whole thing, unless you're planning on feeding a phono signal, like a record player signal, into here, or your iPod. Mystery. I'm just trying to figure out the story of the radio. Well, let's just keep going. Here's the switch. This is probably phono switch. No words. Now let's take a look at this. It's an A23. 50 cycles. No problem at 60. Gives you an idea of the age of it. RCA Victor Canada Limited. Okay, now just behind the switch is a great big resistor. This is what caught my eye earlier. Looking at it with the camera, it doesn't look nearly as bad. With my eye, this thing looked like it was blackened from end to end. The high wattage resistors are worth looking at for sure. The radio designers anticipated these resistors to run with a fair bit of power and have to dissipate a fair bit of heat, which means they're hot. Hot things wear out sooner. Try to keep your cool. Always keep your cool. ABC. Always be cool. So all these capacitors they've got to go. Especially this radio is just covered with dust. It's been somewhere. It could have been in somebody's basement where the humidity is a little high, tucked away somewhere, even sitting in a garage. Who knows? It's a long history in life to these things. That's the back of the antenna connections. So, yeah, they thought these radios out really well. The antenna connection is just a fraction away from the tube that receives the antenna. So these coils are oscillator coils, antenna coils. Offhand, I don't know. There's a capacitor in there. That looks like a tough one to get at. And what's that below it? No, there's it. So below it, that reddish one is a mica capacitor. Those kind are actually highly reliable. Very unlikely it needs to be changed. But the black one, not quite the case. There's some tuning trimmer capacitors here. Looks like you access them through the front of the radio. I'm looking at the front here. Can't access these once the radio's back in its cabin. We're almost done here. So now we're looking at what is probably the antenna coil, but again, I'm not sure yet. Antenna transformer coil. Not sure. And another coil here. You can see the variation in the thickness of the wires on this one. Wow, that second coil there is really, it doesn't even look like wire. It looks like a metal band, but I'm sure it's wire. There you can see the wire leads coming off right there, going down to the terminals. So these coils are really important in these radios. They are built for the radio. They're not standard between models. I'm pretty sure they're not standard. So damage one of these coils, you got to remake it. So you don't want to damage it. So what else is left to look at? Nothing really. I think we've seen everything that needs to be seen. So, okay, now what to do about this radio? Well, first of all, I didn't see a single thing that makes me think I shouldn't try to fix this radio. There's nothing in here that's suggesting this radio can't be brought back to high performance or its original performance levels. I don't think there's any question. All these capacitors got to go. An interesting question now would be, should we try operating this radio? It hasn't been operated for a while, as we can see from the dust on the cords. But wouldn't it be fun to see what it does right from the start? I think that sounds like fun to me. Now, there's a certain amount of risk in doing this, but I can easily minimize the risk to the radio. There could be some kind of defect in here, like a short circuit. Let's say a short circuit on the primary side of the power transformer. You would hope that that short circuit would draw enough power that when you turn the radio on, your fuse or circuit breaker pops open, but there's a good chance that wouldn't happen. What would happen instead is you turn this into a really bad heater, and by the time you figured out what was happening, it might be too late. It might be too late. So how do you prevent that? You need to restrict the power coming into the radio the first time you turn it on. What is it? Oops! What is it hanging on here? Okay, so just need a block. Let's try. There we go. Better. So I'm going to power it up using a cheater cord. These things are dangerous, of course, but I'm pretty conscious of what I'm up to here. Let me just cover that a little bit. Now, in my shop, I power up these projects from an isolation transformer. They aren't really plugged straight into the wall when I'm working on them. So that provides me a fair bit of safety right there. The reason I'm taking the time to tape these up is because these are likely to move around while I'm fooling around here, and I may not keep an eye on them. It's not too far to get to the chassis. I don't want that to happen. So there's also a good chance the power switch here doesn't work. So we'll switch it off to start. The first test is on the power switch. Now, for sure I got this right? Yeah, I'm sure I got it right. So I'm going to plug it into my isolated so just in case this is the first video of mine you're watching, this extension cord really runs back to an isolation transformer. This gray plug runs over to a meter sitting right over here, which I seldom look at. Let me put it over here. A little bit better. This will show the voltage right here. But since I obtained this from my good friend who made it for me, I've also got this guy. Now this guy is really cool. This thing will measure voltage at the outlet, and most interestingly, power being drawn by whatever you plug in here. So I have it sitting here. It will show us the voltage on the radio, show us the power it's consuming if we wish to find out. There's no power in this until I flip a couple switches up here. I'm going to explain this whole deal to you. So this is a master power switch, and this is a selector switch. So this selects dim lights. If I push it down, these two light bulbs, or one of these two light bulbs, is in series with this outlet. So all the power that comes out of the outlet goes through the light bulb. If I plug in something that's got a really serious problem and it tries to draw a lot of power, it will simply light up the light bulb very bright. The light bulb will restrict the amount of power that flows into it, so if we have that initial scenario where there's a really serious problem in here and you only have seconds to figure it out before something explodes, which is not so likely to happen, you'll have a lot more time because the light bulb's going to restrict the power. I can control the restriction by which light bulbs I have in over here. Because this guy has not been plugged in for a long time, the owner couldn't tell me too much about it because obviously he hasn't plugged it in for a long time, although the owner of this radio has owned it since day one. His parents bought it. So this is a long time radio here. I think I'm going to increase the restriction here. I will loosen off one of these bulbs. This leaves just this one here, this somewhat decorative low wattage bulb. That's a lot of restriction on a radio like this. When I turn the power on, all things being normal, this will come on quite bright and stay that way for quite a while. Maybe even be tricky to really know it's not a dead short in the radio. That's okay. I'm not worried about a dead short in the radio, frankly. I really don't think that's what's going to happen here. So, let's see. Band switch, volume control, power switch off, dim lights engaged. Now throw on the power. Nothing should happen. Good. You see this meter jumped up. This guy's come to life. 123 volts. Now there's a whole voltage is appearing here, even though it's going through this light here, but there's no current flow. So no voltage drop in the light. The whole thing shows up here. When I turn the radio on, this is going to drop way off, like maybe down to 40 volts or even lower. In fact, it's going to drop so low, this thing won't work anymore because this thing needs to be powered from the outlet it's plugged in. So this is liable to go blank. This meter isn't from 0, to 120. It's from 100 to 120. So anytime the voltage here is under 100, this meter shows what looks like 0 at a distance. So now, the last thing, for those of you who are uninitiated, with a dim light system, you get a chance to make some interesting observations on the operation of the radio. So what you expect to see is, first turn it on, the heaters and the tubes are cold, and they take quite an inrush of current. That inrush draw will cause the light to come on really bright. As the heaters heat up, the resistance goes up a lot, the current comes way down. We're talking maybe on a radio like this, just taking a wild guess, the inrush current could be 5 amps for a fraction of a second, and then settle way down after that. So not 5 amps here, 5 amps on the other side of the power transformer, but settle down fairly quick. Just giving some time for some thoughts to come in my head, but nothing's coming in my head, so let's turn them on. So the thing to keep your eye on now when I do this is this light, but I mean it's really easy to keep your eye on that, isn't it? Are we all set? Here we go. So I'm watching this light now and trying to detect if it's getting duller. And I think it is getting duller. Yeah, definitely. It's definitely going down. In the camera, your view of things like this is different than mine. It's just not the same. So this is dimmed down a fair bit. Now a couple other observations. First of all, the little lights have come on. Can you see it up there? Yeah, you can kind of see it. The other lights come on too. Got some good light bulbs in there. That's unusual. Not hearing anything out of this speaker, but that's also not unusual. The radio is being supplied with 55 volts. There's a good chance the high voltage is not being produced well at all at this point, and we're really not getting anything out of this radio that we should. So I'm going to reduce the restriction, raise this voltage up, see what happens next by just putting in this light bulb here. Okay, so now we're powering the radio with still pretty low, 80 volts, still pretty low. It may not be enough for the radio to come to life. Let's see. Pretty good. Okay, so nothing scary going on here at all. Those sounds are very reassuring that the radio seems to be operating at this point. We don't know for sure. Seems to be though. And I don't know the position of the band switch. Let's sort that out here. So it's range. They call it a range switch. 31, 25, 19. This must be AM up at the top. So counterclockwise all the way will get us to the AM band. That's where we want to go. AM radio band. that's the most likely one for us. Oh, not there. That's the most likely one for us to hear stations on, considering I don't really have an outdoor antenna hooked up or anything like that. Okay, so it's on the AM band. Let's turn this up a little bit. Good, that's what you expect. All signs are this radio is working. We'll see if we can pick something up now. So those sounds are noise that's in the environment here in my house and my shop. I'm going to move the radio. I'll move the camera here so you can get an idea where the pointer is. So we're heading for the low part of the AM band where we're likely to pick stuff up. Okay, so that sound is probably a short in the tuning capacitor. And that's the thing with all the fins back in here, or all the plates back in there. A little hard to see. Behind the big wheel. Behind the big wheel. Probably shorts in it. So the radio's gone totally quiet because something is shorted out. Oh, short's gone again, so come and go. Could be a bent plate on the capacitor. I doubt it's anything else but that. Okay, we're getting down in the range now where we should hear some stations. So it's a directional antenna, and with it sitting sideways, this is not the way the radio normally is operated. Could be if I set the radio down and rotate it, we get a lot better reception. But I'm not worried about the quality of reception right now. What's that? That's a new sound. Something new in my house making that sound? Yeah, I don't think I've ever heard that particular noise. We're still running the radio with restricted power at 92 volts. That's quite low. You may not be getting the kind of performance out of it you would get with proper voltages on it. But so what we've discovered is a lot of things. First of all, there's no hum in this radio. I don't hear any hum. It's receiving. Well, seems to be receiving fairly well, actually. We'll flip it on shortwave. Let's check it out. So let me get that set. I gotta do some antenna fiddling here. I'll get that going properly. We'll see what it does on shortwave too. Okay, let's see. It's about what time is it? It's 10:30 in the morning here. We're getting into the range where it's really bad to try to pick up shortwave. But just checking the bands again. 31, 25, 19 meter band. So the 19 meter band is probably where we're going to get something. We will see. We will try them all. Okay, antenna on. Let's first flip to one shortwave band. Turn the radio up. How many? Okay, there's no antenna, so it could be quiet because there's no antenna. Now I'm wondering, do you disconnect the link when using an external antenna? So it's not specific about shortwave versus AM. It is possible. I'm just looking for a screwdriver here. What's happened? That's going to be too big. It's possible, no matter where this link is, the AM radio antenna is the loop all the time. And this is just a cheap way of getting some kind of antenna for shortwave. I think that's what's going on here. So we're going to disconnect that. Ground and antenna. Okay, let's first just hook up the antenna wire, see if we hear anything. This radio's turned up full. Not a very good sign, that's for sure. Could be dirty band, could be all kinds of things. Could just be dirty band switch. Next band. Let me tune the radio a bit here, because the capacitor had some shorts in it, and I'm doing this where the capacitor is shorted. I'm not gonna. Nothing. The volume is up full, eh? Okay, last band. 19 meter band. So all the shortwave bands sound kind of dead. Why would that be? Nothing at all. Now there's some tubes with grid caps here. No. If I start. Okay. So I have lots of options on what to do next. It can be everything from testing the tubes, which is generally something you want to do early. Often I leave it till right near the end. You know, especially with a radio that's generally working, I don't jump in there and start fiddling around with the tubes. But this one seemed to be making some noise. Maybe I got to pull them all out, clean them up a little bit, put them through a tester, stick them all back in. Maybe that's where we're going to start with this guy. Tube testing first. Power is off. Plug is out. Okay. I think that's what I'm going to do. We will test the tubes on this radio. See what we get.